Good afternoon, class. Today we're going to discuss section 3.1. Okay, section 3.1, and let's see how far we get. If I can get to section 3.2, we will, but I don't promise. Section 3.1. In section 3.1, we're looking at parabolas, or I should say instead, quadratic functions and models. Okay, section 3.1, quadratic functions. What is a quadratic function? Well, a quadratic function is where the variable, the independent variable, is raised to the second power. Okay, let me give you an example. Here's a quadratic function. This quadratic function, quadratic function. Okay, so let me see. F of x equals to x squared. Now let me say like this. Well, x squared, that's the basic one. That's the basic quadratic function. Okay, can we graph this? Sure we can. It's a parabola. Okay, so here we go. Look, so here's x, and then we have f of x. Okay, so if x is 0, what's 0 squared? 0. If x is 1, what's 1 squared? 1. If x is 2, what's 2 squared? 4. If x is 3, what's 3 squared? 9. How about if x is negative 1? What's negative 1 quantity squared? 1. What's negative 2 quantity squared? 4. What's negative 3 quantity squared? 9. So look, when x is 0, we get 0. When x is 1, we get 1. When x is negative 1, we get 1. When x is 2, we get 4. We get 4. When x is negative 2, we also get 4. When x is 3, we get 9. I'm going to say that's 9, okay? And when x is negative 3, we also get 9. I'm going to say right around there. And so we get this. Whoa. Let me do this. 9. Okay? Do this again. There we go. And so we have this parabola. We call this a parabola, and it should look better than this. There we go. It's a parabola. Okay? It should look a lot nicer than this. All right, so here we go. Yeah, that's better. And so this side is it's ugly, to be honest with you. And so therefore, let me say like this, it's a parabola. There you go. Okay? Parabola. And this is the basic parabola. It's a basic one. It doesn't get any easier than this. This is f of x, and this is x. This is the basic parabola. It's a function. And here is the table. Now, it does not get any easier than this. By the way, we call this the vertex. This right here is the minimum. The minimum point, we call it the vertex. In this case, the vertex is 0, 0. That's the vertex. Okay? And so, the basic parabola. Now, let's mess around with the basic parabola. Watch this. We can mess around with the basic parabola. Okay? So, we have f of x. Watch what happens when I take x here x is being squared, x I call the argument, okay? And so x is the argument, x is the argument, okay? And watch what happens when I take the argument. Here the argument is being squared. The argument is being squared. Watch what happens if I take the argument and I come up with a new argument. Okay? Here I'm going to take this argument x. I'm going to take this argument. Watch what happens. Take the argument and I'm going to add or subtract to the argument. Here I'm going to add 2. Add 2. So this x plus 2 is the new argument. And I'm going to take this new argument and square it. Okay? The x argument is being squared. The new argument is being squared. The new argument is being squared. So x plus 2 is, look at this, the argument now. So here we took x, the old argument, and we added 2. Okay? So I should say like this instead. We took the old argument and we added 2 to the argument. That's it. We added 2 to the argument. Okay? And here it is. That's the new argument. And I'm going to call this, let's call it a different name. Let's call it g of x. It's a function. Okay? Let me just tell you what this would do. We know this is a new argument because it's being squared. This is x plus 2 is being squared. Okay? What this would do, what this 2 will do to this x squared, if you add 2 to the old argument and you square all of that, that's going to shift this parabola 2 units to the left. If you don't believe me, we're going to make a table. Watch this. Let's make a table. So here's x and here's g of x. Watch what's going to happen to the old parabola. This is the basic parabola. This is x squared. Watch what happens when you add 2 to the argument. And now the new argument is being squared. Watch what happens. So let x be, watch this, let x be negative 2. Okay? What's negative 2 plus 2? 0. What's 0 squared? 0. Let x be negative 1. What's negative 1 plus 2? 1. What's 1 squared? 1. Okay. Let x be 0. Okay. 0 plus 2 is 2. What's 2 squared? 4. Okay. All right. If you want to, let x be 1 now. 1 plus 2 is 3. 3 squared? 9. Okay. Let's go down this way. Let x be negative 3. What's negative 3 squared? I'm sorry. What's negative 3 plus 2? Negative 1. What's negative 1 squared? 1. Let x be negative 4. What's negative 4 plus 2? Negative 2. What's negative 2 squared? 4. Let x be negative 5. Okay. What's negative 5 plus 2? Negative 3. What's negative 3 squared? 9. Now we're going to graph this. Okay, watch what happens. Okay, Watch what happens when you add 2 to the argument in the parabola. How do I know it's a parabola? Well, because the power is being squared. If it was being cubed, it's no longer a parabola. And that's what it looks like. Watch what happened. Now we're gonna graph this one. Okay? I'm telling you, when you add 2 to this parentheses inside in a parabola, when you add 2 to the parentheses, to the variable in the parentheses, and that's being squared, that's a horizontal shift. It's 2 units to the left. It's in the opposite direction. Now, this is gonna reflect that, okay? So watch this. Let x be -2. What's g of -2? 0. X be -2, that's 0. See? Let x be -1. G of -1 is 1. X be -1, and we get 1. Okay? See? Let x be 0. G of 0 is 4. G of 0 is 4 right there. You see that? You see what's going on? Let x be 1. G of 1 is 9. Let x be 1 and we get 9. 1 and we get 9, right around there, okay? It's only an approximation, guy, okay? Let x be -3. G of -3 is 1, look. X be -3 and we get 1 right there. Let x be -4. -4 and we get 4. When x is -4, -1, -2, -3, -4, and what do we get? We get 4 right there. Okay? Let x be -5 and we get 9. -5 and we get 9 right around there. And so we got this, look. Oh, this one moved. You see? So, what did we learn? We learned that if you have a basic parabola and you add or subtract to the argument that's being squared, to that argument that's being squared, it's a horizontal shift. In which direction? In the opposite direction. This is x plus 2. We went left. Look. Okay? When you add to the argument, it's a horizontal shift in the opposite direction. Okay? I bet you if I say x minus 2, it would have moved 2 units to the right. Okay? Very good. Now that's adding to the argument. Here's another one. Here is another one. Watch this one. Here's another function, okay? X squared plus 3. And what should we call this? We should call this, here I have f of x, the basic one, g of x, which is a horizontal shift. And let me call this h of x. Okay, watch this. You see this x squared? This is f of x. So here I'm adding 3 to the function, not the argument. So here we added 3 to the function. Okay? Here we added 2 to the argument because this, we did it to this x, and now this new argument is being squared. But here, x plus 3 is not being squared, no. This 3 is added to x squared, different. So here, this 3 is being added to the function f of x. This is f of x. That's why. If you want to make a table for this, you can. But let me tell you guys, when you add to the function, it's a vertical shift. Okay? It's a vertical shift. So this goes up. Okay? So when you add to the function, it's a vertical shift, not in the opposite direction. Let me make a table. Watch what this is the basic parabola, and this is the parabola shifted. This red one is the basic parabola 2 units to the left. And now this one is going to be the basic parabola 3 units up. If you don't believe me, we can make a table. X and h of x. If x is 0, was 0 squared? 0 plus 3, 3. If x is 1, what's 1 squared? 1 plus 3, 4. If x is 2, what's 2 squared? 2 squared is 4, 4 plus 3 is 7. If x is negative 1, what's negative 1 squared? 1, and 1 plus 3, 4. If x is negative 2, what's negative 2 squared? 4, and 4 plus 3, 7. There you go. Let's graph this now. This is going to be the basic parabola 3 units up. Basic parabola. Watch this. If x is 0, we get 3 right there. If x is 1, we get 4. X is 1 and we get 4 right there. If x is negative 1, we get 4 right there. Okay. If x is negative 2, we get 7. X is negative 2, we get 7. 1, 2, 3, 4, 5, 6, 7. Negative 2, we get 7. Negative 2, and we get 7 right there. If x is 2, we also get 7 right around there. And so this is what we're getting. Okay. Okay. So this is, look, from here, we went this way, now we have a new vertex. This is, what's the vertex here? The vertex here is negative 2, 0. Okay. What's the vertex for this one? This is h of x. What's the vertex? 0, 3. Okay. So here's the point. When you add to the function, it's a vertical shift, not in the opposite direction. When you add to the argument, look, this new argument is being squared, it's a horizontal shift in the opposite direction. Okay? Very good. Okay. All right, so we need the room now. We need the room. Okay? Okay, don't forget the basic parabola. I'm going to leave the basic parabola right there. What's going to happen? Let me graph it again. So here's x, and here's f of x. And what does the basic parabola looks like? Well, the vertex is right there, and then 1, 1, and then negative 1, 1, and then 2, 4, and then negative 2, 4, and then we have this. That's the basic parabola. Okay, don't forget the basic parabola. All right, so watch what's going to happen. Watch this. Okay, so this is x plus, let me say minus 3 quantity square minus 2, and this I'm going to call it, what should I call it now? Can I call it Rx? Sure. Okay. All right. So this is the basic parabola, 3 units to the right, 2 units down. Okay. This is a horizontal shift in the opposite direction. This is a vertical shift not in the opposite direction. Okay. So let's graph this one. So watch this. This is the basic parabola. 3 units right. Okay. 3 units to the right. 2 units down. Basic parabola. See the vertex? 3 units right. 1, 2, 3, and 2 units down. 1 and 2. Whoa. And that's the new vertex. Okay, so this really tells me the new vertex. 3 units right. The basic parabola, 1, 2, 3 units right. So this one is telling me the new vertex and 2 units down. 2 units down. So therefore, take this 3, take the opposite of this, and then do not take the opposite of that, and that's the new vertex. This is the vertex. Right there. The new vertex right there. It's the opposite of this, and not the opposite of that. And so now we say from the vertex, whoa, 1 right, 1 up. 1 left, 1 up. Twice right, 4 up. 1, 2, 3, 4 up. Twice left, 4 up. And so now we're getting this. Oh, always mess up. There you go. That's better. So that's the new parabola. Okay? So therefore, the opposite of this, not the opposite of this, is the new vertex. Okay? So that's why I took, this is negative 3, I took 3. This is negative 2, I took negative 2. And that's the new vertex for this parabola. Okay? They call this the vertex form. This parabola is the right here, the way this is written, is the vertex form. Why? Because you can see the vertex. That's why. You can see the vertex when you have it in the vertex form. Okay? Let's do it again. You want to do it again? Sure, we can do it again. Watch this. I'm going to say L of x equals to x plus 1 quantity square plus 5. Can you give me the vertex? Sure. What's the vertex? The vertex is -1, comma 5. Okay? Now look. When the leading coefficient is positive, it opens up. If the leading coefficient right here, if this is ever negative, it's going to open down. Okay? So therefore, this one opens up because this is positive here. It opens up. So the vertex is a minimum. This one here is a minimum. Look, a minimum. That's a minimum. So this vertex here is a minimum. If it opens down, the vertex is the maximum. Okay? Very good. Okay. Now, so this is in vertex form, right here. Can you graph this? I'll let you graph this one, okay? It's the basic parabola. It behaves exactly like this one, except that it's gonna, that's a new vertex, go to this vertex, -1, 5, -1, and then 1, 2, 3, 4, and 5, and that's the new vertex. And what's the behavior of this? From the vertex, look, one to the right and then one up, you land on the graph. From the vertex, one to the left, one up, you land on the graph. So therefore this one to the right, one up, one to the left, one up. Okay? Twice to the right for this one, twice to the right, how many up? 4. So twice to the right for this one, how many up? 4. 1, 2, 3, and 4. Twice to the left, how many up? 4. And this is the new parabola. Copy this one. Okay. So this is in vertex form. So therefore, good class, therefore, here is what I'm trying to get to. Okay? If you ever given a parabola in this form, f of x equals to x minus h quantity squared plus k, what's the vertex? The vertex is h comma k equals to the vertex. Note here, the leading coefficient is +1, so this opens up. If we say this is A, then you don't know if it opens up or opens down because you don't know if A is negative or positive. Okay? But if I don't put an A there, if it's just like this, it opens up. Okay? All right, very good. So that's what they're trying to say in section 3.1. In section 3.1, on page 183, they make this general. To make it general, we say this is A. Page 183. So if A is negative, it opens down. If A is positive, it opens up. If the parabola opens down, the vertex is the maximum. If the parabola opens up, the vertex is the minimum. Okay? So very good. Now, here is a parabola Okay. All right. So here is a parabola that is, here they have this. Okay. All right. In a few minutes, I'm going to show you how to find, I'm going to give you a different formula for the vertex, okay? Different formula. Okay. So let me erase this one. This is the vertex form. Erase this one. Okay. Now look, you see this? This is in vertex form, but sometimes it's not given in this form. It's given as a polynomial, a trinomial to be exact. Okay. How do you square this? How do you square this? Well, x minus 2, x minus 3. X minus 3 times x minus 3 is x minus 3 quantity squared. When you FOIL, x times x is x squared, x times negative 3 is negative 3x, negative 3 times x is negative 3x, negative 3 times negative 3 is plus 9. And so therefore this is x squared minus 6x plus 9. And so therefore you see this? It's in vertex form, but we're going to convert it to like a polynomial form. Watch this. This here is what? X squared minus 6x plus 9 minus 2, which is what? And now this is going to be x squared minus 6x. What is this? Plus 7. And so therefore, this is r of x. This is no longer in vertex form. I'm going to say this is in polynomial form. Okay? Call this polynomial. That's what I'm calling it. I don't know if the book calls it that way. Polynomial form. Okay. It's a polynomial. So, but they're the same thing. They're the same. Okay. Watch this. If you're ever given a parabola, it's a parabola in polynomial form, let me give you, don't forget, which one is this one? This one is, I think I erased it. Yeah, I think I erased it. No, it's right here. The red one. Watch this. I'm gonna give you, if you're ever given a parabola in polynomial form, I'm gonna give you a formula for the vertex. Watch this. Here is a formula for the vertex. Okay. I'm going to call this the x-coordinate of the vertex. X of b equals to negative b over twice a. Okay? And the y-coordinate of the vertex equals to the function of the x-coordinate of the vertex. Okay? In other words, I'm gonna plug in b and a in this formula, and I'm gonna get the x-coordinate of the vertex for this one. It's gonna be the same as this one, which is right here. The formula better give me that. Okay. So I need b and I need a. What is b here? And what is A? A, this is A. A is 1. And what is B? B is negative 6. You see that? Okay, if you're given the quadratic function in polynomial form and you want to find the vertex, this is one way. There's another way, but this is one way. Okay, you need B and you need A. A is 1, B is negative 6. I'm going to plug those values into this formula and I'm going to find the x-coordinate of the vertex. Okay, so the x-coordinate of the vertex is negative B over twice A, which is 1. What's a negative times a negative? 6. What's 2 times 1? 2. What's 6 divided by 2? 3. Yay! Got the first one. That's the x-coordinate of the vertex. Got it? Do you see this? I got the x-coordinate of the vertex. What about the y-coordinate of the vertex? The y-coordinate of the vertex, all I'm going to do is I'm going to plug in 3 into this function. R of 3. Okay. What's 3 squared? 9. What's negative 6 times 3? What's negative 6 times 3? Negative 18 plus 7. Okay. What is 9 plus 7? 16 minus 18. And what's 16 minus 18? Negative 2. Yay! Right there. Okay. So if you're ever given a quadratic function in polynomial form, you can use this formula to find the vertex. Yep, yes we can. Okay, beautiful. Now why is it that we want to find the vertex? Because in applications, the vertex, if the parabola opens down, the vertex is a maximum. If the parabola opens up, the vertex is a minimum. Okay? So that's why we want to find out where the vertex is. Okay? Okay. What's an example? I'll give you an example. Okay. What example should I give you? I don't know. I'll give you this example. Okay. Okay. Let's look at problem number 116, and we're going to maximize an area. Okay? Problem 116. Watch this. This is what it says. Problem 116 says maximizing area. A homeowner has 200 feet of fence to enclose an area for a pet. Okay? Now, it says, if the area is given by x times 100 minus x, okay, what dimensions maximizes the area inside the fence? Okay. Note, if you multiply this times that, what's x times 100? 100x. What's x times negative x? Negative x squared. Let's write it in descending order. This is negative x squared plus 100x. This power tells me that we have a parabola. And this parabola opens down. Okay? This parabola opens down. A sub x, it's a parabola. Now, my question is, this parabola, is it in vertex form or is it in polynomial form? The answer is, it's in polynomial form. It's not in vertex form, okay? Because it is in polynomial form, we can find the vertex by the formula I just gave you. Why? Because in this case, if this parabola opens down, look, this parabola opens down, which means the vertex is a maximum. Okay? And so here, x represents the dimension of this, what do they call it? Of the enclosed area for the pet. X is the dimensions. So therefore, if you want to find the x values that maximizes the area, okay, you need to find the vertex, because the vertex represents, in this case, the maximum point. This is a parabola, guys. Let's find the vertex. The x-coordinate of the vertex is negative b over twice a. That's what we said. Which equals to what? Negative what? What's b? 100. B is 100. Over twice a. What's a? Negative 1. That's negative 100 divided by negative 2. What's negative 100 divided by a negative 2? 50. Okay, so if you were to go to the xy plane, this here is the x-coordinate of the vertex at 50. X equals 50. Okay? I'm going to say this is 10, 20, 30, 40, 50. That's x equals 50. How do you find the y-coordinate of the vertex? Well, the y-coordinate of the vertex is equal to the area of the x coordinate of the vertex, which is 50. Okay? So take this area. You can plug it in there or you can plug it in there. It doesn't matter because this and that are the same function. If you plug it in here, I think it's going to be easier. Okay? So therefore this equals to, I see a 50 there, times, I see 100 there, minus, and I see 50 there because x is 50. And so therefore, this is a 50 times, and what's 100 minus 50? That's a 50. Okay, and what's 50 times 50? What's 5 times 5? 25, 0, 0. Hey, we found the vertex. The vertex is at 50, and then way up here, okay, is way up there. 50 and 2500. Yeah. And then it opens down, and opens down. But the point is, you see, we found the vertex. But this is an application, guys. This is an application, and the vertex represents the maximum value for this function. Okay? X is the dimension of the X is the dimension of this enclosed area. So this enclosed area is maximized when X is 50. So the question says, watch this. If the area given by A of X equals to this, what dimensions maximizes the area for the fence? So this family has a fence, okay? And so a 50 here and a 50 there maximizes the area for this enclosed, it says homeowner has 200 feet of fence to enclose the area. So the enclosed area should be a 50 by 50, okay? And so here's another one. What is the maximum area? The maximum area is 2,500 square feet. That's the maximum you can have this enclosed area. Okay? 2,500 feet squared. Okay. And then it also says, determine the domain and the range of A in this application. Wait a minute. The domain and the range. X, here X could be, watch this, this goes down, down, down. X could be any value that makes this parabola defined, okay? So theoretically, the domain okay, X could be 0, 0 excluding, X could be 0, X can't be negative because a length is not, or a width is not negative. So X could be 0 and up to 100 domain, okay? And what else? And the range, see, this is the range. It could be up to 2,500, from 0 up to 2,500. Okay. All right, very good. The point is, guys, if they ask you to maximize, you need to find the vertex. Okay? And the vertex represents a maximum value. Okay? If they ask you to minimize, you need to find the vertex in applications. So these are for applications, okay? All right, very good. I think I want to do one last thing. One last thing. That's what I want to do. One last thing. Okay? All right. So applications of parabolas. Maximize and minimize. All right. Suppose you're given a parabola in polynomial form. I should say quadratic function in polynomial form. Okay? This one, look. F of x equals to 2 times x plus, now times x squared plus 6x plus, I'm going to say plus 10 plus 5. There you go. All right, suppose you want to write this one, which is in polynomial form, you want to write it in vertex form. You want to write it like this. You want to write f of x equals to a times x minus h quantity squared plus k. I'm going to show you how. Okay. The first thing to do is, well, to get this one into that form, we need to complete the square. And when you complete the square, the leading coefficient must be 1. Okay? So here's what I'm going to do. I'm going to make this leading coefficient 1. I'm going to divide everything by 2. By the way, this parabola opens up. You can find the vertex. Let's find the vertex without doing anything yet. Watch this. How do you find the vertex? The x-coordinate of the vertex is what? Negative b over twice a, right? So negative b. So negative 6 over twice a. What is a? 2. Okay? And so we have this one here, that's negative 6 over twice 2, which is 4. Simplify. 2 goes into 6. Negative 3 over 2. That's the x-coordinate of the vertex. You can plug this into the function. You can do that. F of 3 over 2. Watch this. That's 2. And what's negative 3 over 2 squared? Times what? 9/4. Plus 6 times negative 3 over 2 plus 5. Simplify this. Yes, simplify this. The 2 goes into 4 twice, so this is 9 over 2. Okay? The 2 goes into the 6 3 times, and 3 times negative 3 is minus 9 plus 5. And what is this? 9 over 2. What is 9 plus 5? Minus 4. Okay? Does anybody knows what 9 over 2 is? That's 8 and a half, okay? This is 8 and a half, all right? 8 and a half. No, that's not right. It's 4 and a half. 4 and a half, that's right. Yes, because 2 times 4 is 8 plus 1 is 9. Minus 4. What's 4 and a half minus 4? Which is half. So what's the vertex for this? The vertex is what? Negative 3 over 2. And what else? Half. And this parabola, does it open up or does it open down? This one opens up. So is the vertex a maximum or a minimum? A minimum. Okay, very good. Now, let's write this one in vertex form. We better get this vertex when we write it in vertex form. Else I made a mistake there. Okay. What's the first step? The first step is divide everything by 2 because we need to complete the square and this must be 1. So I'm going to say f of x divided by 2 equals to make room to complete the square, okay? Equals this divided by 2, which is x squared. This divided by 2, which is plus, what's 6x divided by 2? 3x. Make room, push this aside, but divided by 2, 5 halves. Okay? I divided everything by 2. Divide this by 2, and by 2. I pushed it aside, but I still divided by 2. Okay. Now I'm going to take half of 3. Half of 3, because I'm going to complete the square. Half of 3 quantity squared. Okay? And this is what I'm going to add, and I'm also going to subtract it from the same side. So what's half of 3? What's 1 times 3? This is 3 over 2 quantity squared, okay? And what's 3 over 2 quantity squared? 9 over 4. I'm going to take this 9 over 4, and I'm going to add it. And at the same time, I'm going to subtract it. Okay? Believe it or not, I have completed the square. This is a perfect trinomial square right here. So now this becomes f of x over 2. How do we factor this? To factor this, always highlight whatever is being squared. Before you square, highlight it. That's a 3 over 2. Highlight that. Because guess what? When you factor this, it's always going to be squared, and take an x there and just write this plus 3 over 2. That is going to be right there. If you don't believe me, go ahead and FOIL this. You better get that. You will. Now I'm going to add those 2. How do I add those 2? Multiply this by 2. Multiply this by 2. What's negative 9 over 4 plus 10 over 4? What is that? Negative 9 over 4 plus 10 over 4 is plus 1/4. Okay. Now I need to get rid of this 2, so I multiply this by 2, this by 2, and this by 2. I multiply every numerator by 2. So multiply this by 2, multiply this by 2, and multiply this by 2. Okay. The 2's cancel, and watch this. F of x equals 2 times x plus 3 over 2 quantity squared plus what? 2 goes into 4, 1 over 2. And what's the vertex? The vertex, when we have it in vertex form, take the opposite of this, negative 3 over 2. Do not take the opposite of this, 1/2. And that's the vertex, just like before. The x-coordinate of the vertex is negative 3 over 2. There it is. And the y-coordinate of the vertex is 1/2. There it is. So we were right. Okay. Guys, in this case, the vertex is a minimum because the leading coefficient is positive. It opens up. Okay? All right. All right. So I think I can go ahead and do section 3.2. And that's what I'm going to do. In section 3.2, what we're going to do is we are going to solve quadratic equations. Yes, we're going to solve quadratic equations, okay? All right. So section 3.2, solving quadratic equations. So I gotta erase this now. That was section 3.1. In section 3.2, we are going to solve quadratic equations, okay? First of all, watch this. Okay. If we have the following, solve this one, solve x squared minus x equals to 6. Okay? This is a quadratic equation. We can solve this quadratic equation. Yes, we can. We can solve this quadratic equation. To solve quadratic equations, you need to set one side equal to 0. Okay, no problem. Bring it over. X squared minus x minus 6 equals 0. That's the first step. The second step is to solve quadratic equation. The second step is you need to factor the non-zero side. So factor this side. Okay. And so this is x times x. This is 2 times 3. And this must be negative, and this is positive. Okay. And there we go. And so now we say by the zero factor property, I call this zero factor property, we say by the zero factor property, you set the first factor equal to 0, so x plus 2 equals 0, or x minus 3 equals 0. The next factor equals 0. If x plus 2 equals 0, then x equals negative 2, or if x minus 3 equals 0, x equals to 3. And now the parabola, this quadratic equation has been solved. No problem. Okay. Okay. This This was no problem. Okay, watch. Here's what I'm gonna do. I'm just gonna change a simple number. A simple number, guys. And then we're gonna be in trouble. Okay. -4, let's see. Okay. We're gonna be in trouble. I'll just change this number right here. And then we're gonna get in trouble. Watch this. So solve for x in x squared minus x equals to 5. Oh boy. Okay. Just like before, set it equal to 0. And then the next step is try to factor. And now we're in trouble. See? See the problem? We can't factor that. And so therefore, there's got to be another way. There is another way. I'm going to show you. Because we cannot factor, we have no choice here but to complete the square. Okay? Let's complete the square again, just like what we did before. We did a few minutes ago. So to complete the square, the leading coefficient must be 1. So let me push this back over there because now I can't solve it this way. So what I'm going to do is I'm going to complete the square. So I'm going to have to push this back on the other side. Okay, no problem. So x squared minus x, push it to that side, equals to 5. There you go. And I made room. Now, how do you complete the square? You always take half of this. Half of this number. What is this number right there? That's -1. So I'm going to take half of -1 and I'm going to square that. Okay. I always want to highlight whatever is inside because I'm going to use it. So what's half of -1? That's -1/2. Quantity squared. I'm going to use this -1/2. Okay, watch this. Anybody knows what -1/2 square is? What's -1/2 squared? 1/4. So this equals to 1/4. Okay. This is what I'm going to add on the left-hand side and on the right-hand side. Okay? 1/4. Plus 1/4. Plus 1/4. Anybody knows how to factor this? Oh. This is going to be a binomial to the second power. Here write x. And here always write this inside value. Whatever that is. What is it? Minus. What about this? What is this? What's 5 times 4? 20 plus 1. 21. Equals 21 over 4. Okay. Now go class. Now we have completed the square. Now can we solve for x now? Yes, we can. Take the square root of both. We call this the square root property. The square root property says, here is the square root property, okay? I'm going to write it here. The square root property. It says if something square, if z square equals k, then z equals plus minus the square root of k. I should have used dog instead. Let me use dog. Okay. If dog square equals k, then dog equals plus minus the square root of k. Why? Because dog is an expression. Dog is an expression, okay? So here, that's dog. Dog is x minus half. If dog square equals 21 over 4, then dog equals plus minus the square root of 21 over 4. By the square root property, what's dog? X minus half equals plus minus the square root of 21 over 4. You see, we solved. We solved. Bring this over and take the square root of 4. And so therefore, what is x? X equals 2, bring it over, half plus minus the square root of 21 over 2. You can put that together if you want to, okay? So that x equals to 1 plus minus the square root of 21 over 2. And this is going to be two answers, okay? And they are both irrational answers, okay? But the point is, guys, that anytime this is not factorable, no problem. We can complete the square. Yes, we can complete the square. Okay, here's another one. Here's another one. We can do that one. Sure we can. Okay. Let's do it. Let's do another one together. Don't forget the square root property, okay? It's right there. When do we use the square root property? When it is not factorable. If it's factorable, great. Actually, the square root property can be used even if it's factorable. It can always be used. But it's convenient to try to factor. Well, I don't know if it's convenient. Maybe I shouldn't say it. Because sometimes completing the square is easier than looking for the factors. So I'm going to hold before I say that. Completing the square always works, guys. And sometimes it's easier than trying to factor the trinomial. Okay. So watch the following. Watch this. Consider the following. Consider this. Consider. Solve. Solve this one. Solve right here. Yes. 2x squared minus 8x equals 7. Okay, so we have this quadratic equation that we want to solve. So now you're saying to yourself, well, what should I use? Should I try to factor it? Sure, you can try to factor it. But set it equal to 0 first. 2x squared minus 8x minus 7 equals 0. And then you start looking for the factors. Okay. Sometimes you're going to be able to factor it. Many times you're not going to be able to do that. Here we try to factor it. It's not factorable. So instead of looking for factors, I'm just going to forget about this. Let's just complete the square. It's easier. Okay. So forget about trying to factor this one. It's not factorable. You can try, okay? But I don't want to mess with that. Let's just complete the square. Okay. To complete the square, the leading coefficient must be 1. So here's what I'm going to do. I'm going to divide everything by 2. And I'm going to make room there. And I'm going to make room there. I'm going to push this to the side. So divide this by 2. X squared. Divide this by 2. Minus 4x. Make room. Push this aside. Plus, I mean, if you want to say plus 7, it's fine. Okay? You don't have to, but you're going to say it later. Oh, divided by 2, right? Divide this by 2, and by 2 over 2. Almost forgot that. Okay, I'm going to complete the square now. So take half of this in a different color because you want to keep that highlighted, okay? So half of -4. Quantity squared. What's half of -4? Half of -4 is -2. Keep it highlighted. -2. Quantity squared equals to this. I want to keep whatever's inside highlighted. Watch this. What's -2 squared? 4. So this is what I'm going to add to both sides. Okay. Add 4. Oh, there's my addition 4. Now, factor this. How do you factor this? Hello? I'm going to use this number that's highlighted. I'm going to say this is a binomial square. I'm going to write an x there. And now here, I'm going to write whatever's highlighted. What's highlighted is -2, believe it or not. Square this, and you're going to get that. Equals to what? Equals to 2 times 4 is 8. 8 plus 7, 15 over 2. Yeah. We have completed the square. You see that? Easier than trying to look for factors. This always works. Now, by the power of the, what do we call it? The square root property. By the power of the square root property, oh, not in red, guys, not in red, okay? By the power of the square root property, x minus 2 equals 2 plus minus the square root of 15 over 2. Bring it over, okay? Bring it over, and you may wanna rationalize this. I don't like fractions under the square root, so I'll just multiply this by 2 and by 2. Okay, and so what are we gonna get? We're gonna get x equals to 2 plus minus, and this, what is this? The square root of 30 over, and what is this? This is 4, and what is the square root of 4? 2. Okay. And we got it. That's a nice number. Actually, it's not a nice number. Now, by the way, let me put this together, okay? Because I'm going to show you something else. To put this together, write this over 1, and multiply this by 2 and by 2. If you multiply this by 2 and multiply this by 2, and what do we get now? Now we get x equals to, what is that, 4 plus minus the square root of 30 over what? Over 2. Okay, believe it or not, this answer is equivalent to this one. Okay, now, there is one last way to solve the quadratic formula. Quadratic formula, x equals to negative b plus minus the square root of b squared minus 4ac all over twice a. That's the quadratic formula, okay? When you use the quadratic formula, if we use the quadratic formula, we better get this answer, which is equivalent to that. Okay. Now, if you use the quadratic formula, you have to set it equal to 0. So this, you better set equal to 0. So that's 2x squared minus 8x minus 7 equals 0. Okay? So now, what is A? A is 2, B is negative 8, and C is negative 7. I'm going to use those values for the quadratic formula. So x equals to negative b, negative 8, plus minus the square root of b squared. What's negative 8 squared? 64. Minus 4 times a. What is a? 2. Times c. What is c? What is c? Negative 7. Okay. All over minus 4ac. All over twice a. 2 times a. What is a? 2. Okay. You see the quadratic formula, some people love to use the quadratic formula, but watch what's going to happen. So x equals to 8, a negative to the negative is positive, plus the square root of 64, plus, because a negative to the negative is positive, and 8. What is 8 times 7? It's 8 times 7, 56. Plus 56 divided by 4. And so therefore, what is this? This equals to 8 plus minus the square root of, I see 10. 4 and 6 is 10. Takes 1. 6 and 5 is 11 plus 1, 12 divided by 4. Some people get here, and believe me, that's a nice number at 120. They get here and they don't know what to do. Okay? Some people are going to get to this one and they're going to say, well, now what? You have to simplify this. Okay? You see this 120? That's 4 times 30. I'm going to simplify it. Okay? So sometimes this is easier than the quadratic formula. We're going to get the same answer. So x is what? X is 8 plus minus the square root of what? That 120 is 4 times 30. Okay, over 4. And what's good about this? this is 8 plus minus. What is the square root of 4? 2, the square root of 30 over 4. Simplify this. Factor out of 2. So therefore, take out of 2. 2 times a 4 plus minus the square root of 30 all over, and this 4 is 2 times 2. This 2 cancels that 2. And what did we get? We got x equals to what? That 4 plus minus the square root of 30 all over 2, same as before. Okay. Guys, for you, I will learn to complete the square. Sometimes that's easier than even the quadratic formula. Okay? All right, this is section 3.2. Section 3.1 and 3.2, which is did. Yay. Okay. Thank you very much. I'll see you soon. Bye.